Good morning, good afternoon, or good evening, depending on where in the world you are today. And thank you for joining this Tech Strong Learning experience. My name is Amanda, and we want to welcome you to today's program. As a reminder, this session is being recorded and will be available afterward on demand. We will also send you a link to your email inbox after our live session concludes today. We are looking forward to engaging and interacting with you, so feel free to join us in the chat by sharing where you're from, where you're tuning in from, what the weather's like. Feel free to also share your comments and understanding of today's topic for our speakers. That's why we have them here. It's going to be a great program today. You can also send your questions to our speakers within the Q&A panel on the right-hand side of your screen. Feel free to ask questions. We want to engage and interact with you. So without further ado, let's kick off today's topic, building serverless applications on AWS with HashiCorp Terraform. And today I'm joined by several great speakers that I would like to introduce you to. We've got Mike. He's a product manager, cloud providers at HashiCorp, Mike Dahoney. Anton Elekstrom, principal solutions architect at AWS. And we've got Tobias Roth, senior solutions architect at Serverless at AWS. And I want to thank all of you for joining us today. It's going to be a great topic. I'm kind of excited to dive into it myself. So without further ado, Anton, would you like to get us started?
Yes, absolutely. Thanks, Amanda. All right, let's get the slides running and let's start talking about this exciting topic. Okay, I believe you can see my screen. Cool. So feel free to ask your questions using Q&A feature as we go. No need to wait for the end of the session, right? We got enough specialists here that can actually help you with your questions, right? And the topic for today is building serverless applications with Terraform, right? So let's start with setting the baseline, right? What is so special about these serverless applications? Why do we need to have a separate discussion to talk about how do you use Terraform for these kind of applications? Well, serverless applications are different, right? If you look at the spectrum of how do you build your applications, the traditional side of the story, right? This is where, this is how people used to build applications about 20 years ago, 10 years ago. In many cases, it's still relevant today. And this is your traditional, more or less, three-tiered application, right? Before you actually get to application logic, to what that application is going to do, right, you had to consider, okay, I would need a database for this application. How many servers I need to run my, let's say, MySQL database? How do I replicate data, right? How do I set up networking, private, public, etc.? Then what exactly I'm going to be using for application layer, right? What kind of application server, depending on the language, then the web layer, etc. So when you started to build traditional applications, before you get into the actual application, you had to think about the infrastructure that will be required to run that application. This changes completely with serverless, right? Serverless, as the name implies, right? You don't have any servers to manage, right? That's the huge benefit of serverless. So when you're thinking serverless, when you're building serverless applications, your mindset is pretty much right away into what building blocks do I need to implement my application logic, right? Do I need to store binary data? I'll probably use S3. And I don't really care what kind of servers it has under the hood. Do I need to store NoSQL JSON document data? I'll probably use Dynamo. Do I need to run code in cloud? I'll probably use Lambda. And then you connect these building blocks by arrows. We're going to be discussing this later today. So serverless changes the mindset a little bit, right? Because you're no longer thinking about servers. Now, when you look at the way people build those applications, in traditional applications, there's usually a very rigid separation between infrastructure and application team, right? The infrastructure team deals with infrastructure, app team writes code, right? Same happens for CI/CD, right? Even if both teams, both infra and app team, they use CI/CD, usually different tools, different processes, right? The release process can be somewhat manual, right? Including quality control. And, I've been doing this for over 2 decades, right? The last bullet here resonates with me a lot. You need a new database? Well, open a ticket and wait for weeks before someone processes that ticket, does all the approvals, provision the database, etc. Right? Serverless, on the other hand, is much more lightweight, right? You have more shift left responsibilities and trust between the different teams, right? And that promotes operational agility. Now, the term infrastructure, right? Because Terraform is infrastructure as code too. The term infrastructure is a little bit redefined, right? Uh, you know, VPC or EC2 instance, that's what you usually consider as infrastructure, but a function, a Lambda function, right, that is fully owned by the application team, right? Is it an infrastructure managed by a separate infrastructure team? Well, that's a good question. Or a queue or a database table. Note, not the database, but a particular table in a database or event routing rule, right? So developers see those assets as their application resources, and they want to own those resources, right? They don't want to open a ticket to a different team and wait for weeks if they need to make change in something that they consider as part of their application, right? So updating those application resources is commonly a part of developer responsibility, even though technically those application resources are still updated with infrastructure as code tools, right? So, and serverless also going to help you to have more automated guardrails and governance processes in place for quality control. But regardless, what kind of applications you're building, traditional, serverless, in between, it's a spectrum. It's not one or another. You do not want to deploy and operate that by hand, right? Manual is bad, right? I'm a human, and I will tell you that humans make mistakes, right? You want to automate these things as much as possible. Now, infrastructure as code in CI/CD world, this is not new, right? Similar to the way developers or engineers write application code, right? Infrastructure as code allowed engineers to define their infrastructure topology, architecture, right, as code, treat it as code. You would write that definition of the infrastructure using HCL, HashiCorp language, or there are other tools as well. You would put it into source control, and then you would have a continuous integration, continuous deployment process that takes that definition and deploys the environment changes to cloud. Now, this promotes a lot of amazing things, right? For example, repeatability, reusability, right? Once you have that code of your infrastructure as code in Git or any other source control, you can create multiple environments from that snapshot, and you know that they will be identical, right? There is no human mistake possible in between, right? You can encode things like governance, security, observability into that definition, right? So all of these capabilities, right? The fact that you can treat your infrastructure definition as code gives engineers a lot of power, right? Something as simple as I need to roll back to a previous commit. I need to see the history of my infrastructure changes. So a lot of great capabilities are provided by virtue of just using infrastructure as code tools. Now, there are different models, different mindsets in this world, different tools, right? We're AWS, so we have CloudFormation. Obviously, you probably heard about that, right? There are imperative tools where you literally need to code using languages like Java, Python, JavaScript, right, to code your infrastructure definitions. There are declarative tools like CloudFormation and Terraform, where you're not coding your infrastructure definition, you're defining that. And it's up to the tool that you use to actually, get from the state you're currently in into the new desired state, right? So you declare where you want to be, and the tool it's up to the tool to figure out how to get there. So today we'll be talking obviously about Terraform, right? So many things can be said about Terraform. It's a de facto industry standard infrastructure as code framework with millions of downloads, thousands of customers, right? Thousands of various integrations and providers. Specifically, the Terraform provider for AWS was downloaded over 3 billion times, billion with a B, right? That's a huge number, right? Terraform can be used for many, many, many things, right? It's a very generic industry standard tool, but one of the things it can be used for is building serverless applications, which is a very common pattern that we see customers do. So when you're using serverless, the benefits of serverless is you run your code, your applications, without actually thinking about managing servers or clusters or any of that, right? At the moment, we have over 1 million customers using various serverless services every month. It's over a million. And serverless, it processes trillions, tens of trillions of requests every month. So by combining these two awesome capabilities, right, we're going to show you how you can, get even more value. But Mike, can you talk a little bit about this from the HashiCorp perspective, right? So I kind of gave AWS side. What does HashiCorp think about that?
Yeah, thanks, Anton. I appreciate it. I do want to cover that, and I also wanted to cover a little bit of an introduction to Terraform, as well as how we work with AWS. So this first slide, kind of as Anton mentioned, Terraform is considered in many cases a de facto standard for infrastructure automation. And we can see that in some of the numbers here, the hundreds of millions of downloads, 4,000 plus customers, and 430 of the global 2,000. And why I put this customer slide up here first is we've learned a lot about how customers are using Terraform, how they're starting to adopt it, how they reach a point where they know that they need to scale their infrastructure. And so I wanted to walk you through a little bit about what we see from customers, how they adopt and how they scale out their infrastructure as code. So if you go to the next slide, I mentioned we are doing a lot with AWS. So at HashiCorp, all the products we build, we also build in tight integrations with AWS. The one we're really going to focus on today is the Terraform provider. So as Anton mentioned, with the Terraform provider has been downloaded billions of times. It's really the way that customers get started with building out their resources and provisioning on AWS. We've got a number of different awards and tight collaborations with AWS. And then to go a little bit deeper, if you go to the next slide, here's a little bit more about what's the highlights between AWS and Terraform. So as we mentioned, it's highly downloaded, the AWS provider for Terraform. So that's been really recognized by our customers, but we're trying to build out new solutions and help customers scale. So we've actually built out a second provider. So it's called the AWS Cloud Control Provider, just launched in May. So it's a secondary provider for auto-generated resources. So now there's the traditional provider that everyone's probably used to, but now there's a secondary provider where if there's resources that aren't available on day one with the AWS traditional provider, there's a secondary resource that's auto-generated. So I think that's a good advantage for customers. We've also built out integrations for when you're scaling. So it's nice to start out Terraform and build out resources. But we've also built out things for mature customers who want to share their infrastructure as code. They want to make it available for different groups to use. So we've got integrations with AWS products like AWS Service Catalog, so you can manage and templatize your infrastructure as code. And if you go to the next slide, just to kind of take another step back, because I know last time we did the webinar, some people hadn't had as much familiarity with Terraform. So Terraform is infrastructure as code. It helps you build a repeatable provisioning workflow. I mentioned the tight integration with AWS, so there's support for 1,300 plus AWS resource types. It's written on HCL, or HashiCorp Configuration Language, which is declarative human readable language, and you can codify, version, and collaborate on infrastructure as a team. That's a big advantage of Terraform. And we've got some even newer, cooler integrations. So now we're integrated with Amazon Q Developer. So we're using artificial intelligence with AWS to build out code snippets on Terraform through Q Developer. And on our right-hand side, just an example of provisioning an EC2 resource. So as you see, it's easy to understand language that works really well with AWS. And if you go to the next slide. So I mentioned all those customers we work with and different learnings, and really we're here on this webinar to eventually talk about how do you use serverless and use Terraform to scale your business. So most of the people on the phone are probably familiar with application lifecycle management, so where your developers have a workflow to build, they test, and then they deploy their applications through a VCS tool like GitHub or GitLab or something similar. What we are seeing from our customers and what we're kind of building our business around is something called infrastructure lifecycle management. So this is a process where you're teams start to adopt Terraform, but they need to ultimately build platform teams focused on the process of building infrastructure and the related images, deploying them for a workload, and then managing the life cycle of that infrastructure over time. So I think a big theme of this webinar is not just kind of how you get started, not just the tools, but giving you some blueprints for how you can, as your company scales, as your business scales, as you add a platform team. We want to show you a couple tools today that Terraform can help with to scale your business. And then I think my last slide right here is the next slide. So here's a little bit more of just about what I mean by that infrastructure lifecycle management. It's building your infrastructure as code templates, deploying them out to your team, and then being able to manage them in a very self-service way. And a lot of what we do is keyed upon platform teams. So if you're on a platform team or have an inspiration to be on a platform team, that's really what you want to do, to build repeatable workflows that you can share with your customers and add value. And so we're thinking a lot about platform teams as we go through this process. So that's just kind of to introduce the concept. I'll come back to me in a little bit, but for now, I think we want to turn it over to Debasis, who's going to help us to start building.
Awesome. Thanks, Mike.
Sure.
All right. So right now, what we're going to do is to see how we can build a small application with Terraform and AWS serverless services. And let's see, what do we need in order to build that application? What we're going to do is discuss a little bit about theory. What do you need in terms of setting up your Terraform environment, setting it up to deploy AWS resources, talking a little bit about resources in general, for example, buckets, functions, gateways, queues, and all of that. As Anton mentioned, we have to put them like Lego blocks together and build a serverless application, right? So that's what we're going to do, discuss a little bit about theory, and finally close it with looking at the demo, how to create and test a serverless application using Terraform. Next slide, please. So we need three essential tools. We need AWS CLI, which is basically AWS way of interacting with AWS Cloud. We need Terraform CLI, so we can do Terraform apply, we can do Terraform plan, and a couple of other commands that actually take your infrastructure as code and deploy it onto the cloud. And the final tool that we need is AWS SAM CLI. SAM CLI is again a CLI from AWS, which is similar to AWS CLI, but has different purpose to it. It allows you to test serverless applications on your local machine, kind of creating an emulated environment. So we're going to use that as well to test our application locally before we go into AWS Cloud and deploy it, right? So next slide, please. So as Mike mentioned, very first thing that you do with Terraform is to configure it so it can go and deploy resources onto AWS Cloud. So what do we need in order to configure Terraform? We need the provider itself that says that, hey, deploy everything onto AWS. That's where you see the block that says AWS equal to source HashiCorp, what is the version of it, and all of different things. Also, AWS requires a particular region where you are creating the resources. In here, we have taken the example of US East 1 as a region, but if you want to use a different region, you can use that as well. Next slide. Some best practices. You can certainly put your access key and secret key for AWS in your provider block, but do not do it. The reason being, at the end of the day, it is infrastructure as code, so it goes into a source control. Probably you are checking it as a sample into GitHub publicly, or you have your own source control as well, but it's not a good practice to have your access key and secret key or credentials hard-coded in your provider. So make sure that you don't do that on your Terraform code. Rather, go ahead and configure a role for your provider that will be assumed by Terraform during your Terraform plan and deploy process, and that will get temporary credentials, which will expire after a while, right? So it makes your deployment much more secure. So make sure you do not hard-code your credentials, rather use a role in order to deploy your Terraform resources. We do have QR codes for best practices, as well as how you can implement it in your project. Next slide, please. Let's take an example of a small Lego block serverless application, what we are going to do today, right? So we have a scenario of generating a greetings card using serverless application. So we are taking an image as an input, we will process it, we'll generate an HTML greetings card and put it in a destination bucket. The business logic to do that will be hosted on an AWS Lambda function, which is function as a service, where you basically upload a code, trigger it from an event source like an Amazon SQS queue in this scenario, and then the Lambda business code will run and do the exact processing that we just talked about, taking the picture from the source bucket, processing it, and putting it into a destination bucket. That's the whole concept over here. And we're going to talk about a little bit like how to build it, but next slide, please. So we'll start with like creating our buckets. So everything on like Terraform is a resource, right? So it'll start with the resource keyword, and the type of resource in here, the resource type is AWS_S3_bucket. And we'll name the resource itself for Terraform's reference, which is src_bucket. This is not the name of the resource on AWS Cloud, rather just for Terraform to refer it while it is running. If you want to name the bucket, you can give that particular name with the bucket equals to parameter inside the same resource. So source bucket is the name over here. Tag your resources, very, very important. So you will see those tagging everywhere. Apart from that, we also have like a couple of controls, like who will be like making the changes on the bucket. That's the ownership control. Who can access the bucket? That is the access control, and a lot of different type of permission sets we are going to apply on top of the S3 bucket. Why? Because security is again like day zero job. So you need to make sure that your bucket is secured before you put your data on top of that bucket, right? So a couple of configuration around like how to create a bucket, how to control it in terms of ownership and in terms of access. Next slide, please. Then we'll create an SQS queue. So SQS queue will basically take events from the user, and then it will basically buffer it for a while before Lambda can come up, pick it up, and process it. So SQS queue is a very, very simple queue. The name itself, like simple queue service, denotes that. But again, in order to create a SQS queue, you simply need like the resource keyword followed by the type of the resource that you're creating, and with the name of the queue for Terraform, which is greeting_queue. So in this particular case, I have named the same queue on AWS, the greetings queue as well. I'm also defining a couple of other parameters, for example, like SQS managed server-side encryption enabled or not, what is the tag on that particular queue, and bunch of other configurations that you can put into this particular resource. The important thing is, if you want to understand like what are the different parameters available, how do you configure your queue, you can certainly refer to AWS documentation and come back to the Terraform documentation, where it talks about the AWS SQS queue type of resource. You can see all the parameters over there and choose to use whichever are like required for your application, right? Very simple queue creation. Next slide, please. Then we have the Lambda function. Before we go and actually create the Lambda function, we require a couple of things. For example, every time a Lambda function runs, it requires a set of credentials in order to interact with the downstream services. In here, the downstream services are the S3 buckets, because we are hosting an image, we are processing it using code, and then we are finally putting it into a destination bucket, right? So we need to allow Lambda function to do all those things. So that's where like we have this particular slide over here that creates an execution role. The execution role requires two things over here. The first one, the assume role policy that allows the IAM role to be assumed by Lambda service. The second thing is an IAM policy that allows Lambda function to go read the files from the source bucket and put it into the destination bucket, right? So there is a little bit of permission model over here that allows Lambda function to assume the role and then do some certain tasks on AWS Cloud. That is like get object and put object on the source bucket and destination bucket. Just as an example, if you want your Lambda function to do other things, you can also pack those policies in the AWS IAM policy section of your role creation, right? Very simple. Next slide, please. Then let's create a function, right? So how do you create a function? So basically, Lambda is function as a service. We all know that you just pack your code and you upload into the Lambda function. The first way is like you can directly upload your zip file onto your Lambda function, right? And then, and click next, please. And then you can also upload the zip file onto your S3 bucket, and you can pass the reference of that bucket to your Lambda creation process that will also pick up that file and deploy it onto your Lambda function. The third way, if you want to create your Lambda function as a container image, you can also compile your container image and push it to ECR. And from ECR, which is Elastic Container Repository on AWS side, Lambda can also pick up that container image and host it as a function for you, right? So 3 different ways: a zip file directly uploaded onto Lambda, a zip file onto an S3 and referred for Lambda to pick up that file from S3, and finally ECR push for container type Lambda functions. You can do that and Lambda would automatically pick it up from ECR. Let's see like what we have done on our example. Next slide, please. So in here, we have created a Lambda function, again, starting with resource, AWS Lambda function. The name of the Lambda function is greeting Lambda. That is also the name of the function on AWS Cloud. It is a Node.js type of Lambda function running on Node.js 18. We have a handler definition over here that is basically a function inside an index.js file. That's where you will see index.handler. We also have type of memory. We also have like a role assigned to that particular Lambda function, the one that we created just before the Lambda function itself. That is part of the function configuration. The second part is the actual code. Now, Lambda is a hybrid resource, right? So it takes configuration as well as some kind of custom code in it. So that's where we have the function code section of the Lambda function. We are configuring our Terraform file, the resource definition, to take a look at a local file that is basically represented over here with data.archive_file.lambda_zip.output path. And basically that is what we are telling Terraform, right? Hey, go to this particular path, pick that zip file and upload it as part of Lambda creation process. So we are taking the first like workflow that if you remember in our last picture, right? So we're directly uploading the zip file to the Lambda function. Now, Terraform is very intelligent. It can also sense if there is a change in the underlying zip file that you have created. It tracks the base 64 SHA of the zip file. And in case there is a change that you have done on your code, and next time you apply your Terraform or you try to deploy that code, it'll automatically sense the change, automatically like refer to the newer zip file, and it'll upload it to the AWS Lambda function, right? Very simple. Next slide, please. Right. So again, like all these examples and everything, we have already packed it into like a couple of links. Those links are available to you over the QR code, as well as there's a workshop as well right now on your screens. So I see that some of our attendees were asking for links. So if you are still looking for links, we are going to share these links as well with you after the session. Next slide, please. Right. So now that we have developed our application, how do we test it, right? So that is where like we depend on one of the tools called AWS SAM CLI. Next slide. So SAM CLI allows you to emulate a Lambda-like environment in your local machine, which basically is a Docker container with a lot of different configuration that emulates Lambda's own environment on AWS Cloud. So you basically, when you run SAM local commands, it is going to download a small container on your local machine, and it is going to run it. And then it will also host the code that you have on that particular environment, right? So I think a couple of years back, we released the integration of SAM and Terraform, which gives you a seamless experience of developing, deploying, as well as testing your Lambda function on AWS Cloud. So how do you test it? There are a couple of commands, very simple. We are going to see a demo as well, like how to do it, but it's basically like SAM build and SAM local invoke. Not only the Lambda function, you can also test your API gateways using SAM. So we do have like SAM local stat API and SAM local stat Lambda. So a couple of different, like 4 different basic commands from the CLI that you can use in order to emulate your Lambda function or API gateway in your local environment. We do have very good documentation with blogs and examples. We do have the QR code as well over here if you want to refer it. Next slide, please. And again, like if you want to do some kind of like operating system based tricks in order to sense your changes and do a continuous integration of your local code to your AWS Cloud, you can also use watch exec. That is basically your operating system level command in order to continuously monitor your source changes. And if something changes in that particular folder, to automatically apply your Terraform apply. It gives you kind of like synchronous development with your AWS Cloud. But again, some of the choices in order to build and deploy with like real-time traffic if you want on AWS. Next slide, please. Before modulation, we'll quickly do a demo, and then we'll go ahead with our modulation. Let me quickly share my screen over here. Screen. All right. So hopefully you are able to see my screen. And what we have here is an AWS Cloud9 environment that is basically an IDE on AWS Cloud. So treat it as like Visual Studio or something that you're familiar with. On the left hand side, you have a folder structure that you can see. There's a bunch of things over here, a bunch of folders like API Stack, Governance, Lambda, Terraform. There are like modules. We are going to talk about it a little bit, but remember that as an enterprise, if you're managing your code, you are not going to write everything onto a single Terraform file. Rather, you are going to modularize it. So that's what we have done here. We are going to deep dive it into our upcoming like slide decks right over there. But for this particular demo, I have like the same structure like built out for you that we have seen. SQSQ basically being invoking a Lambda function that will go and process a couple of things, right? So very simple thing. If you have a Terraform code project like this, you go into the Terraform folder itself. Right. So I will get into my serverless project and then get into Terraform. The very first thing is like you just say like, hey, Terraform init, and it will initialize your backend. We are going to talk about backends as well, what backends do, how do they help in order to track the changes in your Terraform project. We're going to talk about that as well. But very first thing, you get a fresh project, do a Terraform init, initialize your HashiCorp Terraform on your local machine. Once you do that, then go ahead and do a Terraform plan in order to find out what kind of changes that you're doing on AWS Cloud, right? So Terraform plan will basically give you a snapshot of things that you're going to deploy on AWS Cloud. So in here, I have like a bunch of Terraform files. Terraform basically would consolidate everything and tell me that, hey, these are all the things that I'm going to create. There's a Lambda function, there is an API resource, there is an SQS queue, there is a queue integration, a bunch of different that we are creating over here. And it is going to tell me about all of those. And the final command over here is Terraform apply, right? So when you do Terraform apply, HashiCorp will take, Terraform will take all the configuration and will try to actually deploy it into AWS Cloud, right? So that is what is happening over here. I have already deployed this change for you before we jumped in, but it will go through this entire change plan, and it is going to deploy all the infrastructure on AWS Cloud. If you see here as an output, we do have like an API gateway URL, we have a source bucket, we have a destination bucket, we have a Lambda function, we also have let's quickly take a look at like how we can like test this particular application, right? So let me quickly find out. So this is the command that I'm going to use in order to test my application locally before invoking my cloud-based infrastructure. So what I'm saying here is, hey Sam, invoke this particular command or start this particular Lambda function on my local machine itself with the event JSON that I'm going to supply to you, right? If you look at the event JSON, I'm saying that, hey, this is the ID of my employee, and then create a greeting card for this. So my source image is basically a happy cat. I'm going to take that and I'm going to process it using my Lambda function and generate an HTML file for it, right? Let's see, how does it work? So I have a bunch of different things for you. SAM works with its own infrastructure as code, which is serverless application model. It also works with CDK and Terraform. In this particular case, when Sam saw that, hey, the hook name is Terraform, it is going to do a bunch of Terraform configurations first. It will initialize the Terraform application, plan it, and create a JSON output for you. And then it will also create a small containerized environment that we are going to see in a couple of minutes, right? So it created a couple of metadata files for it to use. And then it is, if you see here, it pulled out some local image from like public ECR repo. That is the emulated environment of Lambda function. Then it mounted a couple of storage, and then it started the Lambda function. If you are familiar with Lambda function, and if you have ever worked with like Lambda logs, this is the exact structure that you are going to see on your local right? So it took the JSON, it picked up the employee records, and it took it as a source file, converted it into a destination file, and created an HTML file for you, right? The greeting card. So if I now go to AWS Cloud real quick, if I go to S3, let's quickly look at S3. And if I go to the destination, almost like 1034, almost right now it got created. Let's see if I download the image, so the HTML file, I will save it. So let me quickly create it, and I got a very nice greeting card to get. Let's go back to the Cloud9 environment. Now that like you understood like how to develop, apply your Terraform, and it has been done, what are the dependencies and all of that. Terraform also allows you to create a module dependency diagram using one of the options. So if you look at over here, I have already generated one for you. So if you clearly tell you which modules are dependent on the primary module, what are the secondary modules, how the dependency looks like, what are the different resources available, you can generate the entire graph and why they are dependent on each other and how they work. And about it.
Yeah, all right. Thanks, Devasis. Okay, let me grab the screen share again. Okay, so you already seen a little bit of that, right? But let's talk a little bit more about modularization. Now, keep your questions coming. Q&A is very active. I love that, right? I was answering questions, Devasis, now it's your turn, okay? And to follow up on a few questions, we will be sharing these slides. The session is being recorded, and the recording will be made public, right? So we don't have any secrets. Everything we talk about and show you, everything will be accessible to you after the session. So let's talk about modularization a little bit, right? Now, as a best practice, you do not want to put all of your infrastructure as code in one file. This is relevant for when you're developing applications in any language, right? Our first applications beyond Hello World, we usually did one big code file, but at some point we learned that you need to modularize that, right? You cannot have one, Java class with 40 lines of code, right? You need to modularize that to packages, to classes. Same with infrastructure as code. You do not want to have this one huge file with your infrastructure as code, right? Will it work from technical standpoint? Yes, it will. Will it make it easier on you? No, it will be complete mess, right? It will be hard for you to understand what's going on there. So our recommendation, right, is to modularize your infrastructure as code. Create modules, split them according to business domains, according to technologies, according to whatever you feel like. You'll see a couple of examples in a second, right? But organize your infrastructure as code collection, as a collection of reusable modules. Because if you do that, you don't need to duplicate efforts. If you create a reusable module that deals, for example, with storage, right, you can maybe reuse it across multiple applications, not just one application that you're building. So let's see an example of that, right? So let's start with a quick anatomy of what a Terraform module is, right? It sounds fancy, but a Terraform module is essentially a directory with several things, right? Now you can see that I have three separate files: variables, main, and outputs. That's a convention. You don't have to have three files. You can put everything in one file and call it mickeymouse.tf. It will still work, okay? But the convention, the thing that makes it easier and consumable and shareable, is to have a variables file which defines the input variables to your module. The main TF, this is where you actually create those resources. And the outputs, that's whatever your module, quote unquote, returns, right? That's the output of your module. So the example you see on your screen here, right? The module that is created here, it has an input variable called source bucket name, right? You know what this is about. Devasis showed you the demo, right? Based on that bucket name, a bucket is created in main.tf, right? You can see that the bucket name variable is used to create a bucket. And the output, right, of that module is the bucket ARN, right? So the input is the name of that bucket. The output is the ARN of a created cloud resource, right? That's the power of Terraform modules. And whoever is consuming this module, they don't need to know anything about internal implementation details, right? So this is really powerful way of defining your infrastructure as code. So for example, here I'm using a module called storage in my infrastructure as code. And the source property points to where that module is, right? Like I said, it's just a directory, right? And I'm passing it two properties: source bucket name, destination bucket name. Okay, easy as that, as well as tag environment, right? The output of this module will be, you saw that on a previous slide, ARNs. So my next module called lambdas, right? This is where I create my functions. You can see that I'm actually passing the information from the storage module to the lambdas module. So lambdas require ARNs and IDs of source and destination buckets. Those buckets are created in the storage module. Lambdas module, not aware of these specifics. It's just asking, give me the ARN of source and destination buckets. I'll put that into the function. So using this approach, you're decoupling concerns, right? You're making sure that your code is modularized, infrastructure as code, right? And each module takes care of one specific scenario. Now, we see customers, modularizing their code. It's a journey, right? And we see it as, something that happens over time, although realistically quite fast, right? So we see that customers start with, when they start onboarding Terraform way, would just create Terraform resources, right? Like you saw before, like this is how you create S3 bucket. This is how you create Lambda function. So when you're a beginner, you're going to be writing that main.tf file with Terraform resources. Now, as you're getting more familiar with Terraform, your maturity level increases. We'll call it advanced, right? You'll start encapsulating those resources into modules. So instead of creating each resource separately, and you're going to give that infrastructure as code to multiple applications team to reuse, right? You'll create a module which encapsulates some logic, infrastructure logic, a logic inside of it. And this way you can share the module. You don't need to share every individual resource. This becomes much more consumable. Now, the next level of this, and we call it power user, is when you take this modularity one level up, right? We call this Terraform aggregated modules, or realistically, those are applications. So imagine this is pretty much what you saw on a previous slide. The Terraform module 1, that's your storage module. This is where you create the buckets and you assign properties to those buckets, and you can enforce things like in your module, like buckets should never be public without ever forcing the module consumer to be even aware of that or concerned with that, right? The second module, that can be your Lambda functions, right? And the aggregated module, you can call it my awesome greetings application. And now you can share all of that infrastructure definition as one aggregated module. So whoever consumes that, they don't need to know internal specifics. They just consume one single module. They provide configuration as input to that module, and that module will give them some outputs as a result. So using this modular capability of Terraform is extremely powerful when you need to write modules in a reusable way and easy to consume way. It's very similar how you use package managers for programming languages, like you package Java packages, right, with Maven, and you distribute them, or NPM modules, right, or packages, whatever they're called, right? So this allows you to have this modularity with packaging for infrastructure as code, and gives you a very flexible and reusable way of building your applications. Now, obviously, you don't always have to start from scratch. There are open source resources and collections of existing tools that you can reuse. One of the popular ones that we see is serverless.tf. It's a community project, right? They are somewhat opinionated. 100% open source community framework, developing, building, deploying, securing serverless applications using Terraform. They have over 100 million downloads. I think it's getting close to 130 million at this point, right? So feel free to explore that. It's an open source community framework that we see popular amongst our customers. I will actually be presenting with the creator of this framework at reInvent. There's going to be a dedicated session talking about serverless and Terraform at reInvent. So we'll be presenting this content as well. So feel free to use it. But once again, right, this is the AWS perspective. We see this modularity, right? Mike, how do you see it from the HashiCorp side?
Yeah, thanks, Anton. I like the way you described it, the beginner, the advanced user, and the power user. So we have kind of a similar phase for how we see customers adopt Terraform. And I think on the last webinar we were at, we covered this a little bit, but customers were asking to go a little bit deeper. So maybe at just the highest level, the kind of common pattern we see for customers adopting Terraform is customers will usually start out with a source available version of Terraform. They'll have singular teams, a real ad hoc approach, and kind of doing infrastructure as provisioning, a real tactical solution. Ultimately, they'll realize that that's not as efficient as it could be, and they'll want to do a centralized approach. They'll want to start setting up some policies, so setting up guardrails around what can be shared, how it can be shared, and the security components. And then they'll want to start collaborating as a team. And we call that the standardizing approach to infrastructure as cloud. And then in the scaling approach is where you really usually have a larger team. You want to move really fast. You have self-service provisioning, automated remediation, so you don't have to touch it every time there's an issue. And it can work across the cloud or multiple clouds and on premises. And if you go into the next slide, I'll show you how we're building that out, not just for Terraform, but for Terraform on AWS. So when customers are getting started, that adopting phase, that's where we have those providers, the AWS providers, to help get started. And we've got a couple integrations as well. And then when customers want to start to land their infrastructure as code and share it as a team, we have integrations for that as well with AWS, like Control Tower, Account Factory for Terraform. And then finally, when you get into a self-service mode, there are integrations built for that too. So I mentioned earlier the integration with AWS Service Catalog and HCP Terraform. So that's kind of the high level. And then on the next slide, we kind of take this approach of lifecycle management for both our infrastructure and security products. So I just wanted to show you the kind of the high level here, but on the next slide, I'll drill into the infrastructure piece, because I think that's what everyone's kind of looking for. Like, what's the blueprint for success for infrastructure lifecycle management? So if you go to the next slide, kind of more specifically in that first phase, the adopting phase, it starts with how do you use, customers trying to figure out how to use infrastructure as code just to provision basic cloud resources, establish a source of truth for resources that are provisioned, and then moving toward basic collaboration capabilities so teams can start to work together. The second phase we call standardizing. Collaboration kind of goes to the next level. So things are happening like you're publishing tested and validated Terraform modules for the rest of the organization to discover and use. And it's usually also the phase where you start thinking about policy and automating policy and enforcement. And then the third phase is the scaling phase. So you'll be able to extend those workflows that you worked on with the rest of your organization and make them as self-service as possible. So that's where features like no-code provisioning come in. And then for operations and security, the next phase is continuous health checks and workflow optimization. So I know there's a lot here, but I do want to kind of break down. I think that's what we were asked for last time, is like, what does this blueprint really look like when I start to work with Terraform? How can I judge where I'm at, and how do I follow that blueprint from kind of starting out as smaller ad hoc teams to building out infrastructure that can be shared across your organization? So I hope that is helpful from HashiCorp side.
Yeah, thanks, Mike. So, again, right, talking about those blueprints, right, we go to this traditional versus modern applications, right, where traditionally you have more of a centralized ownership. Operations team own all the infrastructure. In many cases, they demand to own serverless resources as well. So your app dev teams are kind of coupled with operations team to make architectural changes. You need to increase the memory allocation for your function. This is a very application-specific thing, but you have to go through like ticket to ops team to achieve that, because technically that is done through infrastructure as code, right? So you're becoming pretty tightly coupled, right, as number of applications grow. In the modern world, it's a distributed ownership, right? There's a lot of controlled and well-governed shift left, right? So application development teams own their applications end to end, including infrastructure as code. And operations team kind of evolves to the platform team, provides application blueprints, infrastructure as code modules, as you've seen previously, etc., etc. So this helps organizations to scale and build new applications that do not introduce linear overhead for the operations team, right? Now, we have a webinar dedicated to this specific topic called Scaling Serverless Development with Platform Engineering in about 3 weeks, right? Also with Textron. So you have a QR code on your screens. You can also find it on the internet, right? And we'll share those slides. If you're building serverless applications and you're wondering, so I've built 2 applications or 3 applications and I've learned a lot. How do I scale that to 30 applications, right? How do I scale my 2 development teams to 200 development teams, right? How do customers that have thousands of engineers actually achieve that, right? So this is what we're going to address in that webinar, again, based on, we'll use Terraform as our infrastructure as code tool, so I highly recommend your joining. The last piece that we have is deployments. We talked about development, testing, modularization. So how do you actually deploy those serverless applications to cloud, right? So let's, again, start with a couple of best practices. First of all, do not hard code values, configurations in your infrastructure as code templates. We already talked about modularization. So values that can change, accept them as variables, make them variables, and return as outputs as required, right? What this allows you to do, right? Now, obviously, you don't want to manage all of your environments by hand, right? So you want to have one Terraform template of your application, which can be deployed to multiple environments, development environment, stage, and production. You want those environments to be as similar as possible, as identical as possible. Well, how do you achieve that, right? Now, you've got 2 big questions. How do you apply environment-specific variables, right? And where do you store those environment-specific state files? Now, if you're familiar with Terraform, you know that once you run Terraform apply command, the state of your environment will be stored in a file. It's a state file, right? We'll talk about that in a moment, right? So you want to have an approach where you have that template and environment-specific variables, right? So in development, you might want to allocate a little bit less memory to your function, right? Or have not the most expensive database instance, right? Because it's a development. Staging is more realistic. Production, it's production. But you want to reuse that template. So Terraform gives you 2 ways of doing that. I call them basic and advanced, right? I kind of like this notion. So first of all, when you run the Terraform apply command, you can set the values of the variables, right? You can set variable environment equals production, lambda memory size equals 1024, right? This works, but it's hard to scale that to multiple environments. So the recommended way, and this is what you will see in few guides that we will share towards the end of the session in a few minutes, right, is create a file, a variable file per environment, which means your production environment file will contain values relevant for production, like production and memory size 1024, and your environment file for development environment will have different values. Environment equals development, memory size is 256. So as a result, when you run Terraform apply, you only need to point it to the right environment file, right? So you don't need to specify all of these values separately during the during the execution of Terraform apply. You can store those values in source control. Keep in mind, we're still talking infrastructure as code. You want to code everything you can, right? And just point the Terraform to the right configuration file, environment file, when you execute the Terraform apply command. Now, the state file, which is the output of your Terraform apply command, can be stored in different places. Now, by default, when you're starting with Terraform and you're the only person writing that Terraform configuration, right, it will be stored locally, right? So if you're not even aware of what the state is, of what the state backends are, right, it will just be a local file in the same directory where you executed Terraform. It's going to be .tf state file. Okay, by default, assume implicitly just a local JSON file, and you can open it and see the definition of your current state of the infrastructure. This is good where you're the only person, right? Which is why that's not really realistic. In real scenarios, enterprise especially, you have multiple people making changes to the environment, right? So you want to store that state file in a location where it can be shared by multiple engineers. You can have versioning of that file, etc. So the way to achieve that with Terraform is a remote backend, right? The notion is Terraform backend. This is where the state file is stored. The local backend, we talked about this. Remote backends, there is a variety of backends you can use. I'll just mention two of them. HashiCorp Cloud backend, right? So this is where your state file is stored in HashiCorp Cloud. So if you're using HashiCorp Cloud, that's probably going to be the most common sense option. In addition, you can also use AWS S3 buckets. So that state file, it's just a file. It's the JSON file, right? So you can store that state file in an S3 bucket, which is also officially natively supported type of backend. You can see that on your screen. So you can create different directories or different buckets, keys. You can put that state file in S3 bucket. Now, the way it works, right, is, you define your, and this is an example with S3, right? You define your S3 backend. You see that on the left side. Then you have different configurations, right, per different environments, like development, staging, production, etc., right? And you can put state files in different buckets or even different directories under these buckets. So you don't have to put everything in one place, right? So this actually makes it extremely convenient, right? You can have isolation between environments, right? So we do recommend you isolate environments by accounts, right? Never keep development and production workloads in the same account, right? And this allows you to also have this isolation for the state definition of your applications. Now, let's start a wrap up. We got about, 3 minutes left, right? Let's see what you can do next, right? Because we want to make sure you have actionable items, right, to continue your learning journey, right? So there's a collection of QR codes here. Okay, we have a lot of materials, a lot of content to expand on what we're talking today. We have a multi-chapter guide for building serverless applications with Terraform, and we're actually adding several new modules there for Event Bridge and Step Functions in the next couple of weeks, right? So I highly recommend you read this guide. It comes with sample applications and discusses in depth a lot of things that we've talked about today, right? We have a workshop that you can go through, and we're also making updates to that workshop. We're continuously evolving, adding new scenarios to the workshop as well. AWS Terraform provider docs are very verbose in a good way, right? They give you a lot of examples and show you how to use Terraform. We have a guide for using AWS SAM with Terraform. How do you define your infrastructure as code with Terraform, but then use SAM for local testing? This is amazing capability, right? You define infrastructure as code and you run the simulation of that Lambda function locally. It's just great, right? One critical thing that comes with using infrastructure as code and blueprints is governance. How do you get to a point where every single development team in your organization is following best practices, right? And also, how do you enforce those best practices, and how you detect when someone is, for whatever reason, violating those best practices, security policies. So this is the governance guide for serverless. It's a critical part of scaling any technology across your organization. And we also have a collection of various serverless patterns built with Terraform. So like I said, architecture is fluid, right? You can have many different permutations of various services. So we have a collection of patterns that you can use, right, to accelerate your journey. Those patterns, as well as many additional guides, workflows, posts, videos, etc., are available on serverlessland.com. You have a QR code in the corner, but the website is serverlessland.com. This is where you'll find a lot of content discussing serverless in general and using Terraform for serverless in particular. I highly recommend you hit this website. It's an extremely popular developer resource, right? Keep in mind the webinar we have on September 5th, in about 3 weeks, right? Where we'll be talking, scaling this to a different perspective, right? How do you actually scale the best practices governance across large organizations, right? And with that, I think we're right on time. So I wanted to say thank you, everyone. We've got about a minute left, so Oh yeah, I think the bus has been doing a great job. We have all the questions answered. All right. Yeah, I mean, we can take a couple of questions if we have time.
Yeah, we've got about a minute, so get your questions in now if you'd like to. Just a reminder that in the handout section, we also got Mike, Anton, and Tobias's LinkedIn. If you want to connect with them afterwards, feel free to do so. We shared that with all of you. Yeah. Double checking, we got a couple questions, but it looks like they've been answered. So thank you so much. This has been quite insightful and very engaging. I feel like I learned something today too, right? All right, well, it is time, so we're going to go ahead and start closing out today's program. Want to thank all of you for joining us today for sure. But just a couple of reminders before we close out today's program. We do invite you to please take our survey on, as your input is invaluable to us, helps us create great webinars like this one today. You can also do this by clicking the survey link found in your resources section. We will also email you a recording from today's session shortly after we conclude, and feel free to share that. It'll be available on demand if you want to rewatch it or if you missed something. That's why we do that for all of you. And so last but not least, I want to really thank Anton, Tobias, and Mike for joining us today. Highly insightful. Thank you so much. And it's been a pleasure having you.
Thank you.
Thank you.
Have a good one.
Awesome. And thank you to all of you for joining us today for this TechStrong learning experience. We hope you have a good rest of your day. Bye.
Thanks, everyone.